Hi Algebra 1. In today's video we're going to be talking about solving square root equations. So this is the 10.3 video 1. So these are just in your notebook. We've got I think 5 example problems that we're going to go through. So a square root equation is an equation, so it's got an equal sign, that involves a square root. And these are going to actually feel very similar to the square equations we did last chapter, where we solved them using a square root. All right, so our goal is going to be to get a square root alone, and then that way we can solve it. So if you look at problem number 1 here, it says square root of x equals 9. Well, one way to sort of think about this problem is it's the square root of some number, and the answer is 9. Well, what number is that? Well, it's got to be 81, right? 81, the square root of 81 equals 9. So I know that's the answer I'm going to get to. But the question is, how can I get to that algebraically? So what I do, if I want to free the x from the square root. The x is stuck in a square root right now. So to free the x, I'm going to square it. So what I do is I put the square root in parentheses and I square it, and then I square the 9 as well. And when I do that, the square root and the squared cancel, and I get x equals, and then 9 squared is 81. Okay. Now with these problems, you always want to check your answer, because there are some times where it's actually going to be no solution, but it might seem like there's a solution. All right. One thing that can never happen, you can never have a square root equal a negative number. Just like you could never have a square equal a negative number. So we can't have a square root equal negative, so if that happens, it's going to be no solution. But if I plug this back in, so to check my answer, I'm going to do this in green down here. Check the answer. We get square root of x, which is 81. Does that equal 9? Yes, so we're happy. Okay. All right, number 2. I'm going to go through the same process. What I want to do is free this x plus 3 from the square root. So I'm going to square both sides, and I get x plus 3 equals 16. The square and the square root cancel. And then I just subtract 3 from both sides, and I get x equals 13. Now to check my answer, I plug it back in. So I go square root of 13 plus 3, and I ask, does that equal 4? Well, square root of 16 does equal 4, so again, we're happy. So that works, so I can circle my final answers here. All right, let's try a few more. In a problem like 3, we have 2 times the square root of x plus 5 equals 15. So what you got to take notice of is that the 2 and the plus 5 are outside the square root. All right, and so maybe another way I can show this is by kind of like highlighting. Here's the square root. I need to get that alone before I can square both sides. So just like kind of the pattern we've gotten used to, we got to get rid of addition or subtraction first. So I'm going to subtract 5 from both sides, and I get 2 root x equals 10. And then I'm going to divide both sides by 2, and I get root x equals 5. And now I can square both sides. So I get x, because the square root and the square cancel, equals 5 squared, which is 25. Now before I circle my answer, let's do a quick check. We always want to go back to the original problem. So I'm going to go 2 root 25, because that's what I think x is, plus 5. Does that equal 15? So that's 2 times, what's the square root of 25? It's 5. Plus 5 equals 15. That's 10 plus 5, which does equal 15, so we're happy. And I go circle my answer. So if you notice, kind of the pattern is when you find x, then you want to check it before you finally circle your answer. Number 4 says the square root of 3x plus 1 minus 4 equals 0. All right, once again, I got to get that square root alone. So I'm going to add 4 to both sides. And I get square root of 3x plus 1 equals 4. And now I can square both sides. So we get the square and the square root cancel. 3x plus 1 equals 16. And then I can subtract 1 from both sides. I get 3x equals 15, divide by 3, x equals 5. That's a nice answer. Let's check it. Square root of 3 times 5 plus 1, I plug in my answer, minus 4, and I want to know, does that equal 0? So square root of 15 plus 1 is 16, minus 4 equals 0. Well, square root of 16 is 4. 4 minus 4 is 0. So we're happy. There's my answer. Uno mas. Number 5. 3 root x plus 1 plus 10 equals 1. Okay, so let's get the square root alone. So I'm going to subtract 10 first. Always add or subtract first if that's on the outside. So we get 3 root x plus 1 equals negative 9. Okay, and now I'm going to divide by 3, and I get root x plus 1 equals negative 3. Now, if you're good, if you're paying attention, you can stop right here and say no solution. Because you can never, there's no number where you square root it and you get a negative answer. It doesn't exist. So right here, we could say no solution. But I want to show you what happens if you kept going. So if I square both sides, and since this is a negative, I have to put parentheses around it. If I square both sides, I get x plus 1 equals 9. Because negative 3 times negative 3 is 9. And so that would give me x equals 8. So when I go to check my answer, I would do 3 times root 8 plus 1, because x was 8. So x plus 1 is 8 plus 1, plus 10, and I want to see if that equals 1. I'm going back to the original problem to plug this in. So that's 3 root 9 plus 10. Does that equal 1? Well, root 9 is 3, so 3 times 3 plus 10. That's 9 plus 10 is 19, which does not equal 1, so we're sad. This answer doesn't work, so I cross it off. So that means there's no solution. Okay, which is what we said. You might notice you can do it as soon as you see square root equals a negative. Okay. Alright, so that's all for this video. You've got some classwork that you can work on, and thank you for watching.